Welcome to Gefran's Performance Series PID Controllers presentation. I am John Thoma, Strategic Accounts Manager for Gefran. I will not be taking questions during the presentation, but please write your questions to me. At the end, I'll do my best to answer each of them. I will also provide my contact information if you'd like to discuss with me at another time. The Performance Series is the models 1850, 1650, and 850. The series has three popular DIN sizes, 1/16 DIN, 1/8 DIN, and 1/4 DIN. The Performance Series was designed in parallel with our Value Series and High Limits. Mixing the Performance, Value, and High Limit controllers in the same panel will give you a common look and feel to your panel. The Performance Series meets UL and CE standards. It has also been tested to AMS 2750, an aerospace standard for meeting NADCAP quality programs. It also meets CQI 9 for the automotive industry. Keep in mind, the high limits will additionally carry the FM approval. One of the most striking parts of the controller is the backlit LCD screen. It offers the user a large and bright feedback. The viewing angles are increased and visible in bright lighting conditions is improved over previous LED displays. The controller utilizes four colors, white, red, yellow, and green, to draw the user to the needed information on the process. Looking at the 1850, I first picked up on the bright white process display, probably the most needed aspect for a user as they operate the equipment. Alongside this is the degrees C or F notation, and it could be changed to other engineering units. On the left-hand side is the red output status of the four outputs. The user can easily see how outputs are changing on and off. Moving over into the green under the 1850 process display is the optional ramp and soak or programmer information along with the set point display. In yellow, we can view the status of the controller modes. This feedback to the user will let them see the controllers in run mode or manual mode, or maybe it's auto tuning or possibly in remote mode. Other functions include set point 1 and 2, and the set point ramp is running. The third line of the 1850 showing the word start, this is a user customized display. You can set the customized messaging for alarms or diagnostics. Perhaps it could even instruct the user the equipment is ready to run or load apart or ready to start. Then we have the white bar graphs. These can be set up by the user, but gives you quick feedback on the process status or output percentage. In a motorized valve positioner, it'd give you the position of a valve. Over the years, I've heard concerns over the operator interface. Gefran has addressed some of these concerns. First is the keypad is tactile. You can feel the pressing the switch. Second is right above the keys are green segmented bars. When a key is available to be pressed, it is green. When you press the button, you'll see the green bar change status. This lets you, the user, and feel and see the button being pressed. This function and the user feedback is available in the Value Series and the High Limits too. Whether you're wearing gloves for personal protection or hot parts, or if the plant is noisy, now you're covered. That was the 1850 unit. When we move to the 8th DIN 1650, you'll see the display is smaller and we lose some information. When I look at the right-hand side of the 1850, you see the 8 in and 8 out lights. This is a feature only in the 1850. The 1650 loses these additional inputs and outputs, not just because of the display, but we also lose some space on the screw terminals on the back of the instrument. The 1650 can still ramp and soak, but we lose some of the display feedback. As we move to the 16th DIN 850, we lose a little more of the display features like the third line in the bar graph, but keep in mind, one of my favorites, the tactile and visual keypad feedback is still there. For the inputs and outputs, we have a wide range available. In the model codes, you'll specify which ones you'll need for your applications. How many are available depends on the size of your instrument, with the 1850 having the most. On inputs, we handle 13 thermocouple types, PT100 RTDs, analog signals such as milliamps and voltage, along with the ability to do customization of your own probe types. In addition, there are 2 current transformer inputs, and digital inputs are also available. Output types range from relay, logic output to drive your SSR, analog outputs, and TRIAC. There are a lot of features and abilities in the Performance Series, enough that I'll probably miss a few. All the units are capable of 1 or 2 PID loops. They can be configured as heat, cool, or heat cool. You can Set up the unit to be a valve positioner, create cascade control loops or ratio control. You can easily change the unit to reverse acting or to direct acting outputs as you need. You have multiple PID tuning methods, auto manual control, soft start, up to 16 ramp soak programs can be stored with up to 256 segments. There is a third analog input available. It has specific functions for things like remote set point or valve position feedback. We have multiple temperature alarms and types, loop break alarm and heater break alarm. The function block programming includes up to 32 logic blocks, 8 math blocks, and 3 timer modes. There are passwords and password levels built in the control that you can customize. The Performance series can support a web server and has available both Modbus RTU as a master and slave, Modbus TCP. Even the 16th DIN 850 can have Modbus TCP. There is a weekly clock, and the operating supply can be 24 volts or 100 to 240 volt AC. I'm showing the Performance series as a closed loop controller. On the left, I'm showing the Performance series as a single loop PID controller. It has its connection to a thermocouple input. The output could be an analog output going to a GTF. Last week we heard Matt Fisher discuss the benefits of that power controller. What else could you do with this heating system? How about adding communications like Modbus RTU or Ethernet? Maybe add a digital input switch to make it easier for the operator to switch between two set points. Possibly you could use the process ramp in a controlled way to a specified set point. Change the messaging display to tell the operator to start a process or it's ready to run. You could add ramp soak or tie alarms and external switches using digital inputs or outputs. Maybe indicate a part is present or a door is closed. The Performance series could be a two-loop PID controller. What else could I do with that? Possibly we could link the PIDs or have the set points change via logic or math. Maybe track the actual temperature on one side and use that as a set point on the other, keeping both sides heating together at the same rates. Create a cascade control loop. There'd be a transformation in the picture on how the application would look, but it's a programming option to add that type of a feature. Watch actions on either loop and create strategies in the other, or this could be two independent control loops independently ramping and soaking. What about the third analog input? Expanding on the two PID loop application, maybe we have an analog input from a source like a PLC, or maybe another Performance series controller. The master could be generating a ramp soak profile, but have slave units tracking the master's commands. Maybe we have one master and dozens of slaves tracking the master either exactly or with an offset. Or maybe temperatures need to change based on the speed of a conveyor belt or some other process. When I think of remote set points, maybe this is a multiple zone platen press, downstream equipment, composites, or packaging applications. What if the ramp soak was turned off and this was a conveyor or a continuous process? Keep in mind the third input as a remote set point would be used in the concept of cascade control. With the weekly clock and timers, math and logic functions, this could lend itself to some pretty interesting applications and solutions. When I think of applications for the Performance series, I think of some of these shown. In heat treat, annealing. Annealing involves heating steel to a specified temperature and then cooling at a very slow and controlled rate. Sometimes you'll see the use of two input sensors. The purpose could be to use an average temperature or could be used to make sure and ensure soak times in a difficult and hard to reach area of a part. Heat exchangers. Heat exchangers are used in both cooling and heating processes. Their purpose is to transfer heat between two or more fluids. Heat exchangers could be single loop, but sometimes they will be cascade system setups. The Performance series can handle this application as well. Laboratory ovens are useful in small production areas such as ceramics, glass, gold, or dental products. Usually they require precise heating and cool down. Many times basic logic sequences need to be in place, such as door closed. Consider the energy calculation in applications for oven efficiency. Gas burners. Gas burner applications, a single Performance series can manage the burner system. It can be used with or without slide wire feedback and can display the motorized valve position on the face of the controller. Climactic chambers, also called environmental chambers, is an enclosure used to test the effects of specified environmental conditions on biological items, industrial products, materials, electronic devices, and components. It is common for a chamber to use temperature and also humidity or pressure. The Performance series can manage these 2 PID loop and set point as a 2 PID loop and set point programmer. Milk pasteurization. Both single loop and cascade PID loop controls can be used in the application. Cascade can compensate for steam pressure deviation before affecting the milk temperature. There are two diagnostic functions that I would like to discuss. They are heater break alarm and loop break alarm. They are fundamentally two different functions and easy to confuse them and believe they solve the same situations. Heater break alarm utilizes current transformers placed on the heater power line. We can detect and display the actual current on the heater. Internally, we logically know when the output is supposed to be on or off. During those on-off times, we look at the actual current and compare it to what it should be. In a complete heater failure, when a heater is supposed to be pulling current, we see 0 amps. Then we alarm. We won't know if it's the heater, fuse, solid-state relay, or power supply, but we'll know we don't have heat. Conversely, we have the heater off. Then we see no current. Otherwise, we will alarm off this. The alarm may mean it's a shorted SSR. We can also determine partial heater failure, such as a platen press that has 4 cartridge heaters. Say they each draw 5 amps for a total of 20 amps. When one goes out, we'll only see the current draw of 15 amps. We can use the alarm based on that, not having full current. This feature is useful as some band and cartridge heaters are made with internal invisible parallel circuits, so that a 5 amp cartridge heater may actually be 2.5 heater circuits, but not visible to you. A good application for this could be a packaging machine, where a heated bar for sealing bars tend to be in constant motion. When the heater stops pulling current, you know the temperature will begin to fall, but when does it stop sealing properly? With the heater break, we can see the loss of the power, turn on the alarm, maybe stop the machine and get the heater replaced and running and sealing properly. Loop break alarm is a different concept than heater break alarm. Loop break alarm is monitoring temperature rate of change as compared to the output. In my opinion, this feature is best used in startup situations where runaway temperatures can occur during long unsupervised heat-ups. The controller is looking at the output status, and from that it looks for corresponding increase or decrease of temperature over time. Given this situation, the controller LBA function, loop break alarm, is only active when the output is outside of the proportional band. The controller output must be fully on or off. That's why I say it's best in startup situations. There are many good applications for loop break alarm. I've seen it firsthand in IR heating where the temperature sensor was misaligned with the heating target. On extruders, because of the time to heat, they tend to be turned on and walked away as they heat. With the thermocouple sometimes not seated properly in the well, or maybe it's laying on the floor of the plant. Either way, in those cases, the heats could turn on, not see a rate of rise, and the heats could just run away and we could start melting down the heaters. Likewise, maybe we don't have power out to that heater. We can also sense that because we won't see a change in temperature. So it's possible, one way to look at this is maybe if you start having repeated heater failures, maybe it's possible to warp a tool. I've written a short document on this feature to give a little bit more detail on loop break alarm, and we'll be happy to share. Please reach out to me via my email address at the end of this presentation, and I can send that to you. These diagnostics will give you advanced knowledge of machine problems as opposed to waiting to make bad parts or see it as a temperature problem. In the case of an extruder, have a molten aluminum underneath your machine. Performance series has 3 tuning algorithms to help you determine the optimum PID constants for your process. First is self-tuning. Its suggested use is during the startup or machine commissioning. Then there is one-shot auto-tuning. Use this when you are closer to set point. The unit auto-tunes, sets the PID values, then goes on to control. As the name suggests, it happens only when the user commands it to begin. Auto-tuning, use this one for changing process conditions or settings. This allows quick adjustment to the PID as the process changes. This one's a good concept but some processes may have difficulty with the ever-changing conditions. And this happens, in either the self-tune or the one-shot auto-tune. Predictive maintenance. The performance series can give you feedback on output actuations, so you can approximate machine needs, schedule maintenance, or replacement on the outputs of the controller. There's also an energy counter giving you load current, load power, load energy, total load energy, and total energy cost. All of this information is available from the front panel or through digital communications to the unit. Gefran uses GFX Express to configure all of its microprocessor-based control products. Last week you may have seen the power controller details. If you downloaded the software for the power controller, then you will also have it for the performance series. Gefran gives you one tool on your PC to rely upon. GFX Express will work two different ways. First, if you power the instrument, you can use our TTL micro USB configuration cable. If the instrument has the Ethernet option installed, then you could just use a standard Ethernet cable. The second method, without power, is use the TTL micro USB configuration cable. Power is supplied via the USB, and the instrument's microprocessor can be programmed. This means you could do it while it's in its box, or while you sit in your car or in a maintenance apartment without looking for power. Within the configuration tool, there is a quick wizard. It's nicely laid out with tabs and groups of settings, which has the most common variables and settings readily available for your use. The Express tool also lets you change to other supported languages. There's also a selection for you to preset up to 5 recipes with 25 parameters, making the unit easier to set and use at the plant floor. The configuration tool lets you program the MODBUS RT master communications. If you choose to talk to other Gefran products or third-party products, then you would set them up here. In my previous examples, I showed the Gefran GTF power controller. I mostly assumed a 4 to 20 milliamp output to the GTF. However, I could replace this by using the MODBUS master communications and control the GTF via communications. There is a weekly calendar configurator. You can initiate control and start up certain functions with the weekly calendar. This is where you could set up ramp soak too. You can do it from the front panel. I'd prefer the software because all the parameters are in front of you. And note that it gives you a graphical representation of your profile. As I mentioned, the ramp soak in GFX Express. Within Express, you can set up synchronous profiles. At the top is a 2-channel PID unit. They share the same time-based segments. Maybe these are both temperature profiles, but they could be temperature and humidity. If segment 1 is 30 minutes, then it's the same for both profiles. I say they are shared time-based, but there's a holdback function set or a guaranteed soak, then one channel will wait for the other to reach the target before advancing to the next step. I mentioned heat treat earlier because it's possible to have the 2 probes measuring temperature, but if one area doesn't get the needed heat, then the holdback function could extend the time base out, getting the parts properly processed. In the lower picture is asynchronous profiles. This means they won't share the same time base, so maybe it's temperature and humidity in an environmental chamber, or maybe it's 2 independent ovens or chambers. The function block settings are also in GFX Express. Whether you're doing math, logic, or timers, then you can use Express. In addition, you have monitoring and diagnostic views. I didn't show it well in this presentation, but GFX Express has many pages with monitoring and chart reporting capabilities for testing your equipment. Express can be a useful tool in debugging and documenting the process, in addition to just setting up the process. In this chiller application, we needed specific functions like start-stop, pump control, timer, auto manual. In this application, we have 4 fans for cooling. So rather than always starting fan 1 to cool, we rotate which fans are used. So we wear them out equally. In the past, to do an application like this, you needed a logic card, a timer, a temperature controller. Now you can merge them all together. And with the messages on the front of an 1850 or 1650, this could be a good HMI for the operator. You can control inside a standard menu what is available to the end user from the keypad. It makes it more secure and easier to use at the operator level, while you still have complete access via the Express tool. For example, on this page is the ramp soak. Maybe you would need the operator to change just a few items at the plant floor. In this example, I've selected step set point, step ramp time, step hold time, and the end step for creating the profile. Doing this limits the amount of detail the operator has to know and program. As part of ease of use, but also security, the Performance series can support a freely customized user menu. If you need specific variables changed and easily managed, then they can be placed here. Perhaps a standard menu has too much detail, or you need a little from one menu and some from another menu, then they can be merged to this shared user menu. Gefran has also made it easy to start up a unit without the Express tool. We have set up an out-of-the-box quick configuration. Power it up, walk through the 7 items, and you can start running at basic levels. You can program many of the functions from the front of the instrument. Sometimes it just may be easier to use Express, but you can also use the keypad. Connectivity. We have 4 communication methods. We have the RS-485 Modbus RTU port, the Modbus RTU master port, Ethernet TCP IP slave, and then the bridge Modbus RTU TCP option. All of these can be available on a unit at the same time. The GFX Express tool is always available even when your instrument doesn't have these communication options. In this diagram, on the top, I'm showing a Modbus TCP Ethernet connection to a PLC, HMI, and the Internet, also a web server too. On the Modbus RTU, on the bottom, I'm connected up to 15 nodes. Then if I have a bridge, I can move the data from the Modbus RTU to the Modbus TCP. If you want to know the current or voltage on a Gefran power controller and report it to your SCADA system, it can be done using a Performance series controller as a bridge. For convenience, there is a web server. The pages are already created and the data and parameters are there for you. There are 2 access levels, read-only and read-write with customized passwords. Model codes. This is the 1/16 DIN 850's model code. It's about a 2-inch by 2-inch face. This instrument is easy to specify. Each block across the top goes from A, B, and C, and so on. So just a couple things. Note output number 1, the B option. Master Modbus RTU. Maybe you could use this instead of 4 to 20 milliamp to control your power controller. On the far right column, M is a note for the Ethernet options. Selecting ME gives you Ethernet, but also the bridge. Under function P, on the far right-hand side, that's where the logic, math, and the RTC means real-time clock. So when you're specifying that. But very easy to order and specify, and very powerful controller in a 16 DIN package. This is the 1650, the 8th DIN controller. It's about 4 inches by 2 inches. A lot like the 850, but we get a little more with retransmission, signals, auxiliary inputs. At the bottom, see the areas of G, H, and I in the coding. Towards the bottom left and the bottom right area. So on to the 1850. It's the quarter DIN controller with a face of about 4 inches by 4 inches. It's much like the 1650. The biggest thing you gain here is the additional display feedback on the front, the additional buttons. On the N option, towards the right-hand side middle, you'll see that there's more digital inputs and outputs. Those were needed for the smart fan rotation that I had showed earlier in the presentation. The Performance series is not the only controls from Gefran. Gefran has created a platform of controllers for various needs. When you compare the performance to the value, pictured top middle, we lose a few functions such as it's a single loop PID controller only. It does have many shared diagnostic functions, alarms, and will feel similar to program. It does help on cost. In the value series, we still maintain the bright display and keypad functions. In the upper left is our basic series. The biggest thing to notice is the LED display. It also has fewer programming options, but is a good solid controller. In the lower right is our high-speed controller, the Model 2500. Because of the high speed, it's suitable for fast-acting systems such as closed-loop melt pressure control in an extruder. It can also be set for control of roller tension control. In the lower center is the 3850-2850. We call it a multi-function controller. Out of the box, it can do up to 16 PID loops and data logging. There are options for math, logic, functionality like the Performance series. You can customize the screens too. It's not like a PLC in that you don't have to have extensive programming experience to get it running. It is really out of the box ready. In the lower left is the GFX Turmo 04. It puts 4 PID loops together in a DIN rail package with its cousin the GFX4, which adds PID and power control into one type package. This family has the ability of several communication protocols including Ethernet IP, Profinet, EtherCAT, and MODBUS TCP. In closing, think of the Performance series as a highly precise control, brilliant display, intuitive use with a ton of power buried inside that is easily used. It carries agency approvals. It's a powerful controller that is easy to use. I appreciate you giving up your time today to join me. In a moment, I will try to answer any of your written questions. If you don't have questions now, then I ask that you reach out to me or Gefran to discuss your questions, comments, and concerns. Thanks again.